Hey everyone, we want to take a look at number 11 in section 3.3. It's to calculate basically the derivative of this function. So find f prime of x if f of x is equal to this. I would immediately rewrite this before I take any derivative, remembering that the square root of x is x to the 1/2 power. I'd rewrite it this way. Okay, so this is in section 3.3 where we're learning about the product rule and the quotient rule. And it certainly looks as if we have a product of two different functions of x, this underline and this, right? These are two functions of x. So we can use the product rule if we wanted to. The derivative with respect to x of a product of two functions u and v, derivative of the first function u with respect to x times v, plus u times the derivative of v with respect to x. Okay, so that's what we'll apply here. I'll take the derivative with respect to x of this first function times the second plus the first function times the derivative with respect to x of the second function. Okay, so when we take the derivative here, what do we have? The derivative of x to the 1/2, power rule, bring the 1/2 down, x to the subtract 1 from a half, negative 1/2 power. Derivative of 5 is 0, it's a constant. So this is the derivative with respect to x of the first function times the second plus the first function times the derivative with respect to x of this, and you can see clearly this will be the same thing, 1/2 x to the negative 1/2 as the other derivative over there. Derivative of 4 is 0 again. So here's our derivative. But we need to clean this up now. And to clean that up, I'm going to distribute through the 1/2 x to the negative 1/2 through these two terms and do the similar thing here. And when we do the multiplication, notice 1/2, the first two, 1/2 x to the negative 1/2 times x to the 1/2. What is that? What happens when I multiply those together? Well, notice when I multiply x to the 1/2 times x to the negative 1/2, what do? When we're multiplying like bases to different powers, we add the powers, right? 1/2 plus negative 1/2 is 0, and x to the 0 is 1. This product is 1. You might think about it this way. X to the negative 1/2 is 1 divided by x to the 1/2. So x to the 1/2 times x to the negative 1/2 is just x to the 1/2 times 1 over x to the 1/2. And clearly that's equal to 1, right? It makes sense. So when I multiply this times this, I get 1. Don't forget times a half, I get a half. So this is just a half. 1/2 x to the negative 1/2 times a negative 4 becomes negative 2. 1/2 times 4 is 2 x to the negative 1/2. Similarly here, when I multiply these two together, I get a half again, same thing. And then 1/2 times 5 is 5/2 x to the negative 1/2. Simplify 1/2 plus 1/2 is 1. And then negative 2 x to the negative 1/2 plus 5/2 x to the negative 1/2. These are like terms. Negative 2 is the same as negative 4/2. Negative 4 divided by 2. Negative 4/2 plus 5/2 is a positive 1/2. X to the negative 1/2. So here's the answer. Rewrite this in fraction form. X to the negative 1/2 again is 1 over x to the 1/2. So you can write it to the 1/2 power, or if you just remember going back, 1/2 power is the square root. So I'd have 1 plus 1 over 2 square root of x. Here's my derivative. Very nicely done. Okay. So product rule can certainly be used. However, you might think about this. Is there any way I can get out of not using the product rule? Can I simplify? Yeah. If I simplify this product first by foiling, what happens? First times first, x to the 1/2 times x to the 1/2. Well, what's the square root of x times the square root of x? That's just x. And x to the 1/2 times negative 4 is the outer. X to the 1/2 times positive 5 is the inner. So 5x to the 1/2 minus 4x to the 1/2 is just 1x to the 1/2. Last is 5 times negative 4 is negative 20. Now take the derivative. No product rule needed. What's the derivative of x? 1. What's the derivative of x to the 1/2? Power rule. We already did that. 1/2 x to the negative 1/2. What's the derivative of 20? 0. There's your answer. Boom. Okay. So much quicker and to simplify first. So the bottom line is if you can simplify, make the derivative process easier, that may be a way to go. Simplification is not too bad here. Okay, doesn't always work, but it does here. Okay, hope this is helpful on this one.